Bacteria are usually smaller than fungi. They're simple microscopic cells that multiply by dividing. Their number can double as quickly as every 20 minutes. Viruses are smaller still. They have a protein shell which contains the virus's genes. To multiply, a virus needs to get into your cells. Not all microbes cause disease. In fact, the vast majority are completely harmless, like yeast, a type of fungus that helps bread rise, and lactobacillus, the bacteria used to make yogurt. Only a few microbes are dangerous, but one of the most deadly to humans is a virus called variola. This causes the disease smallpox, and so far, this is the one and only disease that we've managed to get rid of totally. These are some of the last people to be infected. The smallpox virus causes a painful, ugly rash of spots that fill with pus. The disease was often fatal. The battle against smallpox started many hundreds of years ago in China. They realised that by giving someone a mild dose of the disease, it actually stopped them getting full-blown smallpox in the future. In China, smallpox scabs were collected from victims and put into bottles. After a month or so, most of the smallpox viruses were dead or weakened. To make a person immune, the powdered scabs were blown into their nostrils. In India, the pus from a mild case of smallpox was used and smeared into a scratch on another person's arm. In Turkey, Lady Mary Wortley Montagu first witnessed the use of poxypus in 1717.
Using poxypus, how very interesting.
And was so impressed, she brought the idea back to England. But the pus was sometimes strong enough to cause the full-blown disease and death. A way had to be found of infecting people without killing them. In 1796, Englishman Edward Jenner saw that milkmaids sometimes caught cowpox. And this made them immune to smallpox. Edward Jenner went on to prove that if you deliberately give someone a small dose of cowpox, they won't get deadly smallpox. And so the technique of modern-day vaccination began. But it wasn't until nearly 200 years later, in the 1960s, that an international decision was made to try and rid the world of the smallpox disease. The World Health Organization planned a massive program of vaccination. The smallpox virus could only survive inside people, so if everyone was vaccinated, the virus would die out. It took 20 years of hard work to rid the world of smallpox. The next big challenge is to get rid of polio. Again, caused by a virus, this disease can cause paralysis in a matter of hours and mainly affects children under 3.
Match point against polio. Let's all play to win.
But fighting disease isn't easy. Why is it so difficult to completely wipe out a disease? As we know, bacteria are tiny living things, but they can survive in the most unlikely places. From the scorching heat of the hottest desert, to the sub-zero wastes of the polar regions, from the tops of the highest mountain peaks, to the bottom of the deepest oceans. They're here in poisonous sulfur springs and hot volcanic geysers. Incredibly, bacteria have even been found living inside solid rock. But there are some places that bacteria and fungi particularly like to hang out. They especially like warm and wet places. An ideal place for bacteria and fungi to live is on the human body. Scientists have estimated that sometimes there are more microbes living on your hands than there are people living on the Earth. A good way of seeing these invisible beings is to grow them on agar gel. This gel contains blood, an excellent source of microbe food. Place a hand on it, cover it up, and leave it in a warm incubator. 48 hours later, and the warmth has encouraged the microbes to multiply. Eventually, there are so many microbes that they become visible. Each spot is made up of millions of microbes. Many microbes are living on your skin all the time. The question is, does washing remove them? And does using soap really make a difference? We've come to the Skin Research Centre at Leeds University to find out. Simon and Maikwan haven't washed their hands all morning. First, they touch a fresh agar plate with an unwashed hand. Then they wash. Simon washes his hands with soap and water, while Maikwan just uses water. After drying with a paper towel, they each touch another agar plate. Now it's time for some expert help. Richard Bojar is a microbiologist. He puts the agar plates in a warm incubator for 48 hours. So what will the plates look like 2 days later? Normally, you wouldn't take the lid off. The concentration of microbes could be dangerous. But Richard has treated the plates and killed all the microorganisms. Which hand-washing technique has removed the most microbes?
Right then, you're the one who washed your hands with water, aren't you?
Yeah.
Yeah. Well, this is a handprint before you washed your hands, and as you can see, there are microorganisms all over your fingers and your palm.
Right, it's very disgusting.
It is, isn't it? But look, when you wash your hands just with water, all you do is distribute the microorganisms on your hand. You don't get rid of them at all.
All right.
Let's have a look at these. Now then, Simon, you're the one who washed your hands with soap and water, aren't you?
Yeah.
Now, as you can see, before you washed your hands, you've got lots of microorganisms all over your hands as well.
There's lots of them.
There are, aren't there? But washing your hands with soap and water makes a big difference, doesn't it?
There's still quite a lot on there, though, aren't there?
There are quite a lot, but those are the bacteria that normally live on your skin. And it's perfectly natural to have those on your hands.
When is it important to keep your hands clean? So far, we've looked at loads of ways in which microbes can affect your health. They can cause disease, they can prevent disease in vaccinations, and they can even be used to treat disease once you become infected. This is a story of penicillin, and it all started here at St Mary's Hospital in London. In the early 1900s, a doctor called Alexander Fleming was trying to find new ways of treating bacterial infection. Back then, infection was a major cause of death, even in hospitals. In fact, in World War I, many soldiers died from infection of their wounds rather than the wounds themselves. Alexander Fleming was working in this very room, studying a type of bacterium that lives in septic wounds called Staphylococcus. He made his big discovery on the 3rd of September 1928, right here. Fleming was cleaning up his lab when he noticed something unusual. By accident, there was a mouldy fungus growing on one of his agar plates. But more importantly, he noticed that there were no bacteria growing around it. His conclusion was that the fungus must have produced a chemical which killed the bacteria. This was just what he'd been looking for. The name of the fungus was Penicillium notatum, so he called this killer substance penicillin. Penicillin stops bacteria by breaking down their cell walls. The bacteria get bigger but can't divide. Eventually, they burst and die. A substance produced by a microbe which kills bacteria is called an antibiotic. In World War II, the race was on to make enough of this new antibiotic to save thousands of soldiers' lives. Today, penicillin is still an important drug for treating infectious diseases. It's produced on a bigger scale than ever. At this company in Northumberland, they produce over 7 tons of it a day. But antibiotics aren't the answer to everything. For one thing, some bacteria become resistant, so scientists are always on the lookout for new antibiotics. And remember, not all diseases are caused by bacteria. As yet, we still haven't found a cure for the common cold. Why do you think that is?
There's more microbes on Earth than stars in the sky. Yet, microbes are invisible to the naked eye. Microbes travel by air, first class, swim through the sea. On Earth first, on Earth last, infinite, for eternity. They're the dark dancing diva, the wicked weaver of diphtheria, tetanus and scarlet fever. I've got 1,000,000,000 of them on my skin. Fact, 100 million in my gastrointestinal tract. There's more microbes on Earth than stars in the sky, yet microbes are invisible to the naked eye. A weakened body fights day and night. Battle. Colds and flu in human beings, disease-riddled cattle. Virus injects and infects, the body tries to reject it. But by the time you feel it, you're already infected. This vile, violent, viral army is already within the ranks, invading, persuading, raiding the body's banks. There's more microbes on Earth than stars in the sky, yet microbes are invisible to the naked eye. If your food has stamped upon it a best before date, it's because the producers know that microbes won't wait. You've seen fruit in the bowl, milk full of mold, fungi, the fungi is taking hold. Yeast is a beast of fungi, producing carbon dioxide, making alcohol in beer and dough rise. Hey, if it wasn't for fungi, there'd be no blue cheese. What a fantastic tapestry the natural world weaves.